Inclined planes are kind of cool. Which way does the normal force always go? Nope, not down. Normal force. Not up. Nope. Nope. Perpendicular to the surface. So, where is that? That was yesterday or 2 days ago's notes. We said that right here in this little bubble with the idea bulb in his head. So, items going perpendicular to the surface. That means my normal force extends this way. And it told us to draw that first. Then we draw our gravity. And gravity goes towards the center of the Earth. So that's why I drew it straight down, because I'm assuming that the center of the Earth is below us. Even when we're on a ramp. Guys, when I put an item on a frictionless ramp, these are the only two real forces. I'll say it again. When I put an item on a frictionless ramp, these are the only two real forces. So then what's going to happen to the box? In the absence of friction, what will happen to the block? Slide which way? Up? Down the face of the 30-degree ramp. I wrote 30 up here. If you're unsure of what the angle is, it says it right here. So, how does it... If these are the only two real forces, what are you going to do to these forces? To know that it goes down the face of the ramp. Not balance. Add them. They're forces. And when you add them, we add them what to what? Yeah, tip to tail or head to tail. And if I were to move the normal force right here, that's why my end result, and this is going to be a dotted line too, is going to be down the face of the ramp. You see that? Down plus normal is down the face of the ramp. There's a right angle here. And if I hold my pen here and rotate my paper, what's going straight up and down is now going to be slanted. And what is slanted is now straight up and down. How many degrees did I just rotate my paper? 30 degrees. Because that would be how much this ramp rotated as well. Okay? So I'm straight up and down. And this is slanted. I want this to go straight up and down. So I put my pen here and I rotated my paper. 30 degrees. And you can tell because this was flat. And then I rotated my paper 30 degrees. And it's something about there's those geometric rules where you're like something bisecting another angle and then you rotate it or complementary or something. You remember those geometric proofs? I think this is a combination of two geometric proofs. Okay. What we have is a plane and an axis that goes this way versus an axis that goes this way, right? That's pretty much what it is. And we're just rotating the two of them. So we can look at the paper this way if we wanted to because our angle's here. But what do you know is... Wait. What did we call this? Is this purple? What is this purple? Force of gravity. What is the green one? Force normal. And what is the red one? It's not real. It's the net force. The red one is the vector sum of the forces. Right? Now, here's the crazy thing. It's a triangle. What happens if you know the force of gravity and the angle? This one becomes FG. It's adjacent to it. So cosine theta. And your vector sum becomes FG sine theta. So much so that I abbreviated this as Fagramp. Fagramp is the force of gravity down the face of the ramp, and it's always mg sine theta. The way it wants to pull down the ramp is just, and it is part of gravity, and part of the normal force is how it rolls down the face of the ramp, and the combination of the two makes the force of gravity down the face of the ramp. This is the way I'm thinking about it. I turned my paper this way, and I said, gravity is going towards the center of the earth. I'm just looking at it kind of tiltedly. This is the portion of force of gravity that would go down the face of the ramp, and this is the force of gravity that goes into the ramp, which is opposed by the normal. Right? Force of gravity going into the ramp, opposed by normal, whereas that's the force of gravity down the face of the ramp. The combination of the two give me my full gravity, right? But really, the real force is gravity, and then the normal brings us to the face of the ramp, and so it moves down the face of the ramp. Fagramp. I say Fagramp because I don't want to say F-Gramp. That sounds rude. I like my grandpa. He's kind of cool. So F-Gramp doesn't sound appropriate. So Fagramp. We're going to get into that and the math of that. But I will let you know that's what the second half of your Quest 9 goes over. Quest 9 is long. It's 51 parts. But the first part of Quest 9 is actually really easy. The first half of Quest 9 is really easy. And so I would fly through all of that as best as you can. We're going to be dealing with more ramp problems tomorrow. And then that will be like the summation of Quest 9. And it's honestly, if you get the basics of it, it goes really fast going through the problems. If you're struggling with it, it's reinforcing that you're going to be using these same tools again and again, going down the face of the ramp. And it's due Tuesday.